This conference will now be recorded.
Perfect. Okay. Welcome back, guys. So we are having an amazing session from morning. The first one was for around 2 hours, where we discussed what is machine learning, what is data science, what is artificial intelligence, and what is deep learning. And after that, we have understand what is supervised machine learning, what is unsupervised machine learning, what is classification, what is regression, what is clustering. And after that, we jumped into what is labels and what is features. And after that, we started working the practicality of implementing flights delay detection using Spark and mlib. Mlib is machine learning libraries. I have told you and demonstrated very practically on how to download the data and how to import the packages and how to load your data into a data set and data frame. And after the, how do you pre-process your data? How do you make your data ready for your analysis? So I have shown you a lot of things, right? Now, what I'm going to show you is we are going to continue a bit further and let's continue from the point where we left off. Okay, let me show you something. So the last thing we have done, yeah, last thing we have done is we finished analyzing our data set. Now we need to work on stratified sampling. So let's not waste our time anymore. This is most important part. So this everything is completed. We have verified everything here. So I'm moving on to the stratified sampling now. Okay. So you may have a question, Amarnath. Sorry, I'm sorry. You may have a question asking Amarnath, what is stratified sampling? Stratified sampling. I have our team has given a very map. Our team has given a very nice demonstration on that. I can show you that one, and then we can move on. Give me a second. I don't think they have given the theory of it. Yeah, I can explain you the theory. Don't worry. So first, let me explain you the syntax of it, and then I will explain the theory behind it. So the first thing is, let me copy this one here. As we have taken a break for around 2 hours, I don't think our Zeptin will have the latest information, but we need to run through again once again. Let's see. Now, this is stratified sampling. Okay, the stratified sampling is nothing but, in practically speaking, if you want to ensure your model is sensitive to the delayed samples. Delayed samples mean the samples which you have already collected, for example, data frame 1, and in data frame 1, you have initially have a data frame. After that, you have data frame 1. In your data frame 1, you have an additional column. And on top of your data frame 1, you have applied the concatenation functions and did some cache and stored it as a temporary table called flights. Now, this is called delayed samples. When you are trying to put two sample types on same footing, you have to use stratified sampling. The word itself says what it does. It is sampling. What is stratified? Stratified means it is trying to put the data in an chronological order for you so that your sampling makes easy. Very simple. When you want to put two sample types on same footing, we use stratified sampling. Very simple. This samplify API of Spark will be used for that. I repeat, the data frame sample by API, or you can call it as a function. This sample by Spark function is the one that will provide with the fractions of each sample. Now, what happens here is, if you see here, we are keeping all the instances of delayed, but downsampling that not delayed instances to 13%. That means you are making an estimation that all the instances of delayed are on one side, and the downsampling the not delayed instances to 13%. Okay, I am going ahead with a rough guess and see how my predictions would look like. If it, I'll go forward like this with a guess that I'm downsampling my not delayed to 13% and do random checks and proceed. If that doesn't look good for me, I'll come back and reduce this 13% to something else. Okay, that's my approach. So stratified sampling is very important. As this is a demo, I don't want to go much deep into it, but definitely it's very important to understand what is sampling and stratified sampling. There's a big difference between sampling and stratified sampling. We can deep dive into that little later. But today, for you to understand why am I using this sample by Spark API, I just wanted to put the sample types on same footing. And also I wanted to downsample the not delayed to 13%, which I'm doing here. On top of it, once this is done, I am using the fractions and 36L. Okay. And then I'm asking it to, like, see, I'll tell you one example. This is all well done. Good, don't worry. Now, I just want to show you something. If you see here, after you have implemented the bucketizer option here, do you see you have df2? That df2 you have created temporary tables, right? Like that, now I'm going to apply stratified sampling, and after I apply stratified sampling, I will create a or replace a temp view, and I'll ask that I'll ask my Spark to store that as a table name called flights. Perfect. Now that training data will be grouped by delayed option, and it will show me the total count. Let me see what happens now. Once again, guys, val test data is defined into data frame 2 API, which is nothing but the data frame 2 will have your test data, and your training data will have the sample by option, where you have downsampled your not delayed instances 13%. We'll talk about it more practically in next few minutes. Bear with me for a few minutes on that. This is running. Perfect. Now it has done the work very perfectly. If you see here, the scalar collection immutable map double double map 0 13 10 means your 0 is 4578, your 1 is also 4558, means delayed and not delayed. Earlier, if you remember, 0 is delayed and 1 is not delayed. So now we have 4758 records in delayed, and sorry, 0 is delayed. Delayed you have 4758 records. In not delayed you have 4558 records. Perfect. Now you understood what is stratified sampling. We will deep dive into stratified sampling more practically, because stratified sampling is a very big concept. I don't want to spend so much time on this, but for you to proceed further today, all you need to understand is stratified sampling is used to downsize your sampling, or if you have to put two sample types and compare them or work on them, you need to do simple was classification means yes or no, if yes what, if no what. For you to do yes or no, you need to know 0 or 1. To reach to that point, you are samplifying. That's it, simple. Now let's come to the next point. The next point here would be, let me show you that. This is very, very important. I'll have to spend a bit of time to explain this for you, which I will do now. Okay, now if you see here, we are talking about feature extractions and pipeline. Okay, one important aspect here is any machine learning package will have labels and features that has to be added as columns to the data frame, which we did. Okay, practically speaking, I repeat that. Focus carefully. This one, this one, this one, this one, this one are nothing but columns. All right. What I'm doing here is I am I wanted to ensure my machine learning package or my machine learning process has a label and a feature which are called vectors. If you ask me what is vector, vectors are nothing but what you are going to get out of your what are you going to get out of solving your problem is called a vector in a nutshell. So your ML package should have a label and a vector, that to be added as a column for your input data frame, which I've done. Now you need to set up a pipeline to pass the data through the transformer in order to extract the features and labels. Very simple. How do you pass a pipeline to pass the data? That is very important, a question mark for every one of you here. Now, for that one, I'm using a Spark string indexes in the pipeline to encode a column of string values to a column of number of indices. Okay, let me show you that in the PPT if I can find, then that will help. Not here, this already discussed. Yeah, this one. This is the pipeline. Now, look at this example. What do you understand? You have a string indexer, you have a bucketizer, you have a vector assembler, you have a random forest. A pipeline is nothing but a pipeline is a chain multiple transformers and estimators together in a ML workflow. Okay. For freshers to understand in a better way, your ML package should have a label and a feature vector to be added as an additional column for you to input in a data frame. I'm repeating this third time. I'm aware of it because I wanted to make sure you're understanding the things in the right way. Once that is done, which we have completed, you need a pipeline setup. That pipeline setup is the one that will allow your data to pass through the transformations and extracts the features and labels. Perfect. For you in Spark, if you want to do that, you have to use Spark string indexes. Perfect. This Spark string indexes will encode a column of string values. Means, okay, let me explain that practically. Let me go here. You have columns, right? This one, this one, this one. Let's first take let's take an example. Your column, your string value column must be proportional, or it must take your reference column and then continue to further building a model. Okay, which means your column is encoded. Encoded means the values that are present in the column is having a number of indices for the value. For example, the best way how I can explain you this one is, if you see here, I'm setting up an input column, I'm setting up an output column, and for my output column I'm giving an indexed. Okay, which is like it is plus. My column name plus index is nothing but this will be acting as a encoding for my column. Okay, a simple example I can say is string indexer will acting as a encoding a column. Encoding a column means encoding the values that are present in the string to a column of number of indices of carrier. Okay, very simple. If you run this query, you'll get the output. On based of that output, I'll give you a practical example of it. Okay, let me run this one and show you what I mean to say. It's running. Let's wait. Okay, if you see here, what is the categorical column? It has taken carrier, origin, destination, date of week, origin as categorical columns. So your machine learning model is now ready with the categorical columns. This will be your string indexer. This string indexer, what it has done, it has encoded this one with this one, this one with this one, this one with this one, this one, sorry, this one with this one, and this one with this one. Now you can ask me, what the hell is that? That hell is nothing but the string indexer simply encoded a column with the number indices. Number indices mean for the machine learning model to do the prediction for you, it need a proper reference, or it need a proper unique encodement. So for that purpose, it has given this unique number. That's all you have to understand in the way string indexer is working. Okay, now after this, let me move on. I know this bit is this will be a bit confusing, but I'll explain you once again. Once I run the whole pipeline, you'll understand the process. This bit is done. Now let me move on to next bit. This is other interesting part. You have to understand what I'm doing here. Only then it makes sense. Okay. Now this bit is done. The way we can really work on the next set of actions is, vector assembler. Okay, I'll show the slide here. So you understood the string indexer. String indexer has just encoded your, I'm talking about this one, string indexer. Your string indexer has just transformed or mapped your column into indices. Let's go one step down. Okay, now see here. The string indexer transform your map strings into numbers. Okay, so what I have done is I have done map indexer. Okay, I'll show that. 1 minute. Let me, if I reach that stage, or I'm still one step before of it. Yeah, this is all theoretical stuff. Let's not worry about it. Yeah, if you see here, this is what I was focused on. You have a data frame, you have a string indexer, and then you have a bucketizer, and then you have vector assembler. After the vector assembler, you have a data frame plus label plus features. Okay, we are going to do this one actually. I'll share this slide for every one of you. You can use it for your reference. Don't worry about it, but try to understand the whole underlying process on how the algorithm is built. Okay, so data frame part, you're clear. String indexer, I already explained you now. Bucketizer, you know what we did. We need to understand the vector assembler now. Okay, now let me show you that. So guys, the vector assembler is used in the pipeline to combine a given list of columns into single feature column. Simple, very simple. Vector assembler. What is a vector? It can be features what you're expecting to come as a solution for your problem, right? Now, this vector assemblers I'm using here is simply using a pipeline, and that pipeline will combine a given list of columns. What are the columns here? 1 column, 2 column, 3 column, 4 column, 5 column. These 5 columns are now given into a single feature column. Okay, that's what I'm trying to do. So I'm using a new bucketizer. The input column will be departure delay and output column will be label. Okay, if it is 0, it's not delayed. If it is 40, it's delayed. Okay, on top of it, what I'm doing is I'm explaining future columns. What is future column here? Future column means, once again, the vector assembler does that work. How does vector assembler does? Vector assembler simply puts the list of columns into a single feature column. Perfect. That single feature column will be your career indexed, your destination indexed, your origin indexed, your date of week indexed, your origin underscore destination indexed, and then your career departure hour, your career departure time, your career arrival time, and your career arrival time, and the district. Now you're putting that features into a vector column form. Let me run this one and show you how this works. Very simple, boss. You have a labeler. Labeler means, you know, right? You need a label and you need a feature. While creating a label, you are telling my labels are nothing but 0 or 1. What is 0? Not delayed. 1 is 0 is delayed. 1 is not delayed. 1 is not delayed means if it is less than 40, it's 1. If it is not, that is 0. That is my label. What is features? Features will be my columns that are already stratified sampled on top of it, which is vector assembled. Okay, for that one I'm creating these columns. Now I have a labeler and I have a feature columns. Now columns are different, feature columns are different. Feature columns are Based upon your predictions, what you're trying to expect is called feature columns. Perfect. Now you are creating a variable called assembler. That assembler is having vector assembler. Vector assembler does what it is supposed to do. Like all your reference list of columns will be put into one single feature column. Okay. So input feature is feature columns and output column is features. Let me run this one. I'll show you what it does. Perfect. It's running. Superb. Let's see. You will love if you write this code by yourself, which I did, because if I start writing the code, it will take so much of time. That's the reason why I have not spent. That's the reason why I've created one notebook already with a name called testing notebook. So you can understand that. It's running still. It's finished. Now understand, guys. Your labeler is machine learning feature bucketizer, which has a reference. Perfect. What are your features? Your features are carrier indexed, which are stored in an array. Now you have an assembler also. Your vector assembler is this one. Perfect. Label is ready, feature is ready, assembler is ready. Let's go on to next step. Now next step is you are creating a random forest estimator. What is random forest estimator? I'll show you that. I'll show you that. This is one important bit you need to understand. Let me get that for you. Okay, now let's go back to our Spark notes which we have taken. Okay, do you see here? We have applied label indexer, we have input column, we have output column. Amazing. We have feature indexer, we have vector indexer, features, index features. This guy has put index features, but I have put features and labels and feature columns. You cannot just you cannot have say you cannot have as is. His approach is a bit different and my approach is a bit different, but the ideology is same. We have applied the index labels, adding metadata to the labels column, fitting the old data set into include all labels in index. That's what I did. Here he applied string indexer, even I did the same, and then he applied vector indexer, vector assembler, and this guy have got labels, feature columns, and also assemblers. Now understand the basic. He has split the data into random split, which we already did it. So we can do once again before building the model, but I'm focused on this one. Okay, if you see here, val is a variable, rf is a random forest, is equal to new random forest classifier dot set labels dot set features and set num trees. I will go very deep into what is random forest, how do you estimate a random forest, or how do you do the ROC, and how random forest practically works in the background, what is the formula of it, all I'll talk later. Today our plan is to finish the end-to-end implementation of algorithm, okay, or machine learning model. Okay, so this is set label column, set features column, set numbers is 10. Okay, this 10 is nothing but the reference parameter. Now let me go back. Where is my this thing? Now if you see here, I did the same thing. Val random forest equal to new random forest classifiers, set label column is label, set feature column is features. Okay, because I have labeler here, that will be my label. I have features and features will be feature. Okay, now let me quickly check if I have to make anything else. No need. That makes sense to me. It's running. It finished. Now this has created a new what you call a result explaining this is your random forest classifier reference. Okay, that's done. Now setting up a pipeline with feature transformers and model estimators. Okay, let's go to the document here. One minute, I wanted to show you pipeline, feature transformer, and model estimators. Where is the pipeline here? This is what they have done. First, chain indexes and forest in a pipeline. See the syntax here. val pipeline equal to new pipeline. Same like what we did for val random forest. As I said, pipeline is very simple. Don't break your head on understanding what is pipeline. Pipeline is very simple. It is the one that passes your data through each transformer steps in order to extract the features and labels. That's what it is. You may ask me, Amarnath, you earlier said we already got the features and labels. No, we have not got the features and labels yet. We are preparing our data to get the features and labels. Okay, makes sense. Now, let me first get this from here. This is done. So I'm gonna get this one now. Take it here, put it here. Now, if you see here, val steps. What is steps? Steps mean you are creating the pipeline steps. What are you doing in the pipeline steps? In the pipeline steps, you have used the string indexes already. What is string indexes? The output of this one. Okay. And what are you doing it? You are combining it with the array of labeler, assembler, and random forest. What is assembler? This is the assembler, right? Just remember, this is your assembler. Got it? Now, your random forest. This is your random forest. So the steps is you are telling pipeline, my dear pipeline, first go and take the string indexer, which is this one. This is nothing but a one step of transformation. Okay, take this one and an array of this one with assembler, which is this one, and then this one. Okay, now that is called a pipeline. Your pipeline is nothing but one first step plus second step, third, and fourth. This pipeline is this is the steps variable, and this steps variable has done three functions, has done one function which combined four steps, and now that pipeline is going to be a new pipeline creating the set steps. Okay, set stage for steps. Very simple boss. New variable, go and take this one dot set stages of what steps is this. What is your step this? What did your step do? It created string indexer, and then it combined everything. It didn't create a string indexer, it has taken the string indexer. I'm sorry, I'm going a little fast. Let me calm down. Thank you. Let me run this one. It's running. Very good. It finished. Superb. That's nice. Now, this is a very crazy part of it. Let me explain you that. Setting up a cross validation with the parameters. This will take a bit more time than expected. Bear with me for 1 minute. Okay. For you to understand what is a tree estimator, evaluator, what is param grid, I need to take you through hands-on with machine learning, scikit-learn, TensorFlow book. A lot of very nice presentation videos are made by me, which I will show to you at a later stage. But right now, all you need to understand is you need to validate whether your model is running well or not. Okay, that is called training the model. Training the model means we would like to determine which parameter and which values of random forest classifier will produce the best model. I repeat, this is a very important step. You need to understand this. We have to determine what are the parameters, what are the values of random forest classifier that can produce the model. To use the parameters or to use the values, you need to know which one to use when. I'll give a little more explanation on that. The common technique will be the k-fold cross validation. This k-fold cross validation means where your data is randomly split into k partitions. Okay, k partitions can be 10 partitions, 15 partitions, or 20 partitions, whatever it is. Now, When your data is split into partitions, each partition will be used as one testing data set, while the rest are used for training set. That's what I told you in the beginning of today's morning session. When you stress the data more, you get the more accuracy. That's what this k-fold is. K-fold means if I take 10 folds, in every fold I make, my data will be stressed a lot. The first time what happens is, in each when I say 10 folds, it's 10 partitions. In each partition, one will be used as training set and all other will be used as test set. In this way, it runs the your model runs on the training set, goes and validates on test set. So this is partition 1. It does the same work on partition 2. It does the same work on partition 3. It does the same work on partition 4. Like that. It rigorously does so much of work on each of the partition and finally does a quick validation and check on how the results are looking. So this is why I've been telling from morning, stressing a lot about data. If you stress the data, you get a right output. Okay, that is what about your k-fold is. In other words, sometimes you need to understand this. Carefully observe, guys. I have set threefold cross validation here, right? Now I'll tell you what happens in the background. Every model that is generated using the training set and evaluated with the test set, you have to remember this. I told you very clearly, for data science, training set plus test set is very, very important, because you train your model on one data set and you test those results on the test data set. Okay, so the model parameters leading to the highest performance are the best model. When will you come to a conclusion that this is the best model? You have a test. Check with number of folds 3, check with number of folds 4, check with number of folds 5, check with number of folds 5, 6, 7, and come to understanding like that. Now, here in this Spark, what happens is Spark machine learning is supporting a k-fold cross validation with a transformation and estimation pipeline. I already told you pipeline is nothing but series of steps which takes your data through the steps so that you can get the features and labels. This k-fold cross validation is the same thing. It can also be called as a transformation, or it can also be called as an estimation pipeline. Okay. Now, using the cross validation called grid search. Okay. Now, I'll show you the Spark documentation which makes easy for you. Okay. I'm searching for it. 1 minute. Give me 1 second, guys. I'm looking for it. What you need to do is fold. What is that we used here? 1 minute. We used param grid. You should have param. You should have grid. So we are talking about logistic regression here. Let me go to random forest classifier. Yeah, this one. They have taken the pipeline. They have made predictions, and then they used 1 minute, guys. 1 minute. Set mat categories. They have taken 4 categories. Automatically identify category column and then index them. For some reason, I don't see the k-fold validation used in this reference article, but it should be definitely used for the purpose. Okay, let me explain you that. It will understand. It will make things better for you. Okay, very simple, boss. Param grid is nothing but you are using a param grid builder. It is having an add grid, which is first of all random forest dot max bins, random forest dot max depths, random forest dot what we call number of trees, and impurity, which is called Gini. Okay, I'll explain you more clearly. Yeah, this one. This is towards data science is one of the best reference I always follow. By the way, I'll give you a list of top-notch best contributors in the data science world who will make your journey easy. Follow them. I have learned a lot from them, and you will also have to follow them. You will learn a lot from them, and I'll also give you a reference links to the people who always ready to help. But as said earlier this morning, first try by yourself. Find a way to get your problem solved. If you're stuck, don't ask for the help. If you are completely lost and got no idea on how to approach, then you can ask for the help. Okay, so we are talking about param grid here. Random forest. Okay, let me open this one. This guy is using Python, but don't worry, it will be more or less the pattern looks same. Yeah, see, he's using cross validation, and that's what I told you. We use k-fold cross validation. Random search, scikit-learn. Don't worry about scikit-learn. Okay, we did this one. He simple. If you understand, if you just compare, he is using from scikit-learn. This is one library, whereas we had a package. Okay, that's it. Mm, See, random grid, they have used n estimators, maximum futures, maximum depth, minimum samples leaf, bootstrap. What we have taken here, for you to understand, you have taken max bins, max depth, number of trees, if add grid purity, and Gini is nothing but accuracy element in random forest performance parameter validation. So don't worry much about this. I will very clearly explain you each and every bit in every transformation or every model. Uh, for example, for you to understand, I have to explain what is param grid. I'll explain what all the each and element does, which will work very practically on next sessions. So I don't want to waste time on this one. However, what we have to focus is we are using a cross validator with the parameters, a tree estimators and evaluators. And then we are used param to search through the RF parameters. And after that, we have used deep trees that are potentially more accurate, but for more likely to overfit it. So now cross validation is equal to use cross validation. You have used a pipeline, which you know. You also use an evaluator, which you know. And you also did estimate parameters with number of folds equal to 3. Okay, this is straightforward, very simple. If you follow this document and if you understand each and every step what it is happening underneath this, you will write the program, or you'll start coding by yourself, which we will learn in subsequent classes. Everything cannot happen on the same day, so let's take it slowly. Perfect, it has run now, it has finished. Okay, so guys, remember very simple thing. We have used the param grid builder here. The param grid builder is nothing but it is used to construct the parameter grid for the model training. If you ask me what is a parameter grid, it is an evaluator which will evaluate the model by comparing the test label column with test prediction column. Okay, and then we used a cross validation for the model selection. Model selection means the options which I have chosen or the approach which I have taken, is that the right one, or can machine it, can the model advise me some other best with giving me the predictions. That's what it is. I would like to repeat it. This step is nothing but you use param grid. Param grid is a parameter builder. The parameter builder will give you a parameter grid for the training. You can define an evaluator. What does an evaluator does? It evaluates. What it evaluates? It evaluates your model. How is it evaluating? By comparing the test table column with the test prediction column. Superb. I understand that. Now cross validation is also, you understood that cross validation is for model selection. Now the very important thing that actually doing your work for you is the cross validation in turn uses the param grid builder, because it iterates. The cross validation iterates through your param builder in such a way the maximum depths you have given, the maximum bins you have given, the number of B trees you have given. We'll discuss about these things later. What is max depth, what is max bins, what is num trees, we'll discuss later. Don't worry, you'll get a very proper knowledge on that one. And you have given number of folds equal to 3. So considering this one, this is one fold. Observe carefully, boss. Very simple. Max bins 100, max depth 2, max trees 5. Max bins 100, max depths 2, number of trees 5. So how many you have? This is 1, this is 2, this is 3, this is 4, this is 5. Okay, this 5 is nothing but it has done the evaluation for you, and it has done the cross validation for you. That's what it is. So we are at, now we can guess, we can get the best model. How would you get the best model? In order to get the best model, you need to print out the futures importance. You know what is a label, you know what is a future. Now the results next, what we are expecting will be the desired destinations are the most important features what we want, right? Now let's see what will happen. I'm almost there, bear with me. This is very simple, don't worry about this one. You'll get the, you'll get the whole practicality of it later. Okay, see boss, now your future importance is nothing but you have run a pipeline model. Okay, your pipeline model, you're asking it to fit with the best model as instance of pipeline model, and your string size will be taken in with reference to your random forest classification model. You have to understand these elements, we'll discuss about it later. And then 1 minute, yeah, you got assembler input columns, array, sort by, for each, feed, and then important, which will be given feature columns as features and importance as imp. This one is really a complex step. This complex step is actually the one that prints out the feature importance. I'll explain about this bit later, but today's agenda is to show you the whole machine learning process. It threw error message telling pipeline model is not found. I might have missed one step before this one. Yeah, I have not used this step. If you see here, I have used this step is important. I'll show you what the mistake is. I will tell you what the mistake is. If I can get this one here. So my pipeline model is nothing but I'm asking to take the cross validator. This is the cross validator. Whatever the values are stored in this variable, take that one, fit it into training data. Okay, fit it into training data means go and transform it kind of thing. Okay, now let's run this one and let's see what happens. It's running. Very good. It will give you importance now. That importance will help you to understand how things will work. It's running. We have to wait because this is the biggest step that runs the whole process. 81%. 81% still running. Let's wait. If you have identified, this is the one that has taken so much time when compared to all other steps. That explains the importance of it. 88%. 98%. 29%. 98. Perfect. Superb. I appreciate that. Now, if you see this one, what happened? This pipeline has a cross validation performed, which is ML. It used this one, and it has got the feature importance. In this feature importance, it has got features as all these bits. All right. Now, I have already defined this as, if you see here, let me show you. Yep. See these things. These are my features, right? That's what I'm saying here now. Index, just indexed, care index, and all these things. So, what do you understand here? It's very simple. This is the feature importance. Feature importance means the results that show that the scheduled departure time and the origin destination are the most important features for you. Yes, I'm happy. I appreciate that. Now, what happens is, next step will be 1 minute. Yeah. Next step would be you have to take the best estimator parameter and stress your data a bit more so you'll understand what output it gives you. Okay. This step, it is doing a best random forest model by simply using the cross validation process in one with the depth of 4, 20, and 100 bins. Because if you go here, 1 second, guys, 100 bins, right? You got it, right? I gave it 100 bins. What is the depth? Depth 2, depth 2, number of trees 20. So it is going to do with 4 first. This is 1, this is 2, this is 3, this is 4. Okay, it's entropy, so don't worry about it. Gini, and what is Gini, what is entropy, we'll talk later. So now let's come back. What this step will be doing is, val best estimator means it is trying to find the best random forest model that can be produced using the cross validation process with 4, 20 and 100 bins. Let me run this one and show you the results. I know it will be a bit confusing because this is your day one or you are trying to understand, but my agenda today is to make you aware of things, how things looks. Okay, now let's see the results here. It is given Genie 420. Okay, cool, perfect. I got the result as what I'm expected. Now let me go on to next step. Now next step is predictions and model evaluation. So what this step is doing, you need to understand very carefully. The performance of the model, the way how it works is, it can be determined using the test data that has not been used for the training or cross-validation. I have been repeating this n number of times from morning because that's the importance of it. Though you have written the best model possible, if that doesn't run well on the training data or cross-validation data, you have messed up. So always be aware, the performance of model have to be determined only on the training set or the cross-validation set. Now I'm going to transform. Now I'm going to do that. We need to transform the test data frame in the pipeline model, which will pass the test data according to the pipeline steps. Perfect. I understand that. The pipeline model knows what it has to do, so you don't worry about it. I'm just using a process. I'm just asking it to use a process called pipeline model. Let me first take that one. Don't worry about these terms, guys. You will get everything properly. But this is only day one for you. But this will. I just want to make sure nothing is rocket science. It's just data science. To make you all feel comfortable, yes, you can start learning it. I've taken this extra step today to show you the whole step. Now, simple. I'm using a step called pipeline model. This pipeline model is again an API Spark function. What it does is, according to the pipeline steps through the feature extraction stage, it will estimate the random forest model that can be chosen by model tuning. Okay, so now I'll run this one. Let me show what happens. If you see here, the predictions is done. It is stored into a new data frame, right? I'm happy now. I'm almost done. Now we need to understand, are we right? Now, evaluating the prediction accuracy. I have been talking to you about ROC, a top area of ROC and bottom area of ROC, blah, blah. So don't worry what ROC is, but right now you need to understand what is false positive rate and what is true positive rate. We have slides prepared for that. We'll talk about it very nicely when once we deep dive into next step of actions. But now you need to understand, the accuracy prediction can only be done with ROC. That ROC is nothing but evaluation. So now I'm going to use this one. Okay. Don't worry about this. We'll talk about this in more deep later stages. Okay. Today we want to complete the whole process. So area under ROC is nothing but you are using an evaluator and you are using that evaluator to transform it using an evaluation step of predictions. What is predictions? This is predictions. This prediction is nothing but a pipeline model has been applied on your transformer. Okay. Now I will ask it to show me the area under ROC and area under ROC plus. This is ready. Let me run it. That's running. Cool. Good job. Now this is done. Now calculating some more metrics. For all of you to explain this one, I have to tell you what is true, false, positive, 100 specificity, and I also have to show you true positivity rate sensitivity. Don't worry about this. For now, I'm running it to calculate the metrics. I promise I will make this more easy for you moving forward, because for this single bit to explain, I have to spend 2 to 3 hours, because I have to explain you what is true positive, what is false positive, and how true positive with false positive and how false negative with true positive is looking like. For example, 1 minute, let me check. I think I have not copied it properly. Where did this pre came from? 1 second, guys. Let me first run it. I'm not sure where this pre came from. Oh, it's running. Okay, that's fine. So see, this thing is this thing is nothing but it's a wrong story. You have a labels, you have a predictions. On top of it, there is one thing called false positivity, false negativity, true positive, false positive, false negative, true negative. That is just nothing like 0 or 1, 1 or 0, 0, 0, 0, 0, 0, 1. Simple, I tell you. If it is 0, 0, 0, it's 0, right? If it is 0, 0, 1, it is 1, right? Like that, your machine learning models does a different way of processing the picking out true or false, or picking out or making classification. We'll talk about that later stages, don't worry. Okay, now this is done. So next step will be, let me see the results. Yeah, value pre is not a member of double. Okay, let me take out this one. Let me run this now. Okay, I got everything perfectly. I got no error messages. Now the next step would be, you need to understand the ratio correct, ratio wrong, and ratio. See, the ratio correct is correct ratio, ratio wrong is wrong ratio, true positive is which is correct, true negative means it thought it is true but it is not true, false negative is it's thought it was false, it was really false, it was thought it is false but it was not, it thought it was false but it is really false. This kind of things we'll talk about it later stages, but I want to complete this whole process now, just to make sure everyone understands how the whole machine learning process works. Let me do this one also. Superb, it is also completed. So now next step is, we need to get the positions and recalls. Don't worry about what is position and recall. I'll tell you. Position and recall is like, are you happy? Are you happy with the way your machine learning has identified the predictions, or would you like to recall, or what is the parameter at which you would like to perform the checks once again? Okay, this is also running. Let's wait for a few minutes. Now, let me see the predictions. This is also completed. So if you see here, if you run this now, perfect. So label is this one, prediction is this one. If 0 is 0, 11 times is classified correctly, 13, and 0 is label, 1 is prediction, so it is 16. This is CRS dep hour, departure hour delayed by. So if you see this, this explains you very clearly that how the CRS depth hour is calculated based upon the labels and predictions using the models. Okay, now a quick summary on the whole steps I've done. There are plenty great tools to build the classification models. Apache Spark has just an excellent framework for building the solutions for business problems, which I've tried to show you now. This machine learning algorithm cannot answer all the questions perfectly, but what they can provide is they can provide an evidence for the humans to consider when interpreting the results. Perfect. Now, in this example, we could do a better flight delay predictions with more timely fashion. If you have weather, if you have holiday, if you have incoming flight details, if you have airport problems, that will also give you more accurate results. So all of the data which we have used, all of the reference we have used, and all of the steps the documentation followed in Spark will be the same. And all you need to understand is your pipelines, your estimators, your bucketizers, your vector assemblers, your feature labels, your feature columns, and how you link that pipeline and do a random forest classifier. If it is not random forest, use linear regression. If it is not linear regression, use something else, and then come out with the proper output. So this is how I made a prediction. Now my prediction is having label, prediction, and CRS to the power. CRS is carrier. The CRS depth hour is nothing but you have your. Let me show you that. I forgot what the CRS depth hour. Scheduled departure time. So this scheduled departure time is this one. So based on this one second. Where is that? Where is that? Yeah, it's here. Based on this, 000 means 00 means delayed. One is not delayed. Basically, what happened is this is true. Okay, 000 is fine, but if you see here, uh, one is not delayed and zero is delayed. Perfect. One is delayed, one is delayed, zero is not delayed, one is delayed. So your labels are this one, your predictions are this one, and departure hour at which time? At 22 hour, at 14th hour, or at 15th hour. So this is how you can make an prediction. As I said, I reckon the predictions are not 100% right, but they provide an evidence. In this process, we have did the whole uh, implementation process of the machine learning random forest classifier implementation, and the reference documentation can be found here. The first thing you need to understand is load the data into data frame. I just want to confirm once again, this works like this in Spark. It works a bit different in Python and R, but the skeleton of building a machine learning model will still be the same. First step, load the data. Second step, pre-process the data. Third step, prepare the data. Fourth step, use your future labels and column future labels and uh, use your labels and futures, and then try on how you can split your training data and test data. After that, see which model you want to apply. After you apply that model, test that model's performance parameters. Once you test the performance parameters, go to next level and validate those performance parameters. Once you've done that one, go ahead and run the model pipeline again and see how that works. Once you're happy with the predictions, stress the data with using more folds, more cross-validation techniques. That is the whole journey of the machine learning. Hope you have enjoyed the three series of three series of videos today on how to build machine learning models, how to start thinking, and how to start following to resolve the business use cases. So today you understood what machine learning is. Once again, tomorrow I'll show you another project on housing prices, which is a standard ABCD for any machine learning model. So I'll show you that also. After showing that, we'll properly jump into topics and understanding each and everything. So I also want to show you my course index structure, my blog, and the way the place where you can put your questions, the place where you can subscribe to my knowledge based articles, my references, my freelance project experiences, and what I do. I would be doing it very massively. I commit to upload videos on a day-to-day basis. So I'll keep you posted on those details in next few days. Stay tuned. I sincerely appreciate all your guys' support. If you like this video, please do like. If you don't like it, just hate it. I will try to improve it. And if you have any comments, if you have any questions, if you are a starter, if you are just passed out guy, don't feel shy. Put your questions. You have all my details. So get in touch with me. We can keep this growing. All the very best and good luck, everyone. See you later.